Now let's talk about the concept of probability function. So a probability function explains how the total chance is distributed among the possible values of x. So we are talking about a general function using which we can calculate probabilities of different value of x. So earlier we took an example of fx is equal to x divided by 6. It was a function for rolling a dice. Here x would be 1, 2, 3, 4, 5, 6. So all the possible values of x would be ranging from 1 to 6. So basically, using this probability function, we can talk about the chances or the probability that the function is distributed into. Now there are two key properties of a probability function. Number one is the probability of a particular value of range of values must be between 0 to 1. So we talk about the axioms of probability earlier as well, that the maximum probability that can be assigned to a function would be 1, which means that there is an absolute certainty that this event will happen, or the lowest that we can do to 0, which means that the event will not happen. The probability cannot be negative. The probability cannot go above 1 because that's the maximum value that can be assigned to a probability. And for a probability function as well, the range would be from 0 to 1. Then the other axiom of probability is also applicable, which means that sum of all probabilities would be equal to 1. So if you're talking about here for this function, if we put all of the probabilities, if we calculate first probability of x is equal to 1, probability of x is equal to 2 and up to 6, the answer, the summation of all of these probabilities would not exceed 1. Or if we calculate the probability of the sample space of all the possible events in that particular sample, then the probability would be equal to 1. Now there are broadly two types of probability function. Number one is probability mass function and the other is the probability density function. A probability mass function or PMF is a probability function for discrete random variables. So earlier we talked about two set of variables, discrete and continuous. So if we are calculating the probability mass function or probability function for discrete random variables such as rolling a dice, as we discussed earlier, or for a coin or any event in which chances are finite, then we would be calling it a probability mass function. This function gives us the probability that a certain random variable will take a particular value. Now again, there are two properties of a probability mass function. Number one is probability x would be greater than or equal to 0. Of course, again, the minimum value that can be assigned is 0. So the probability that will be calculated using the probability mass function would be either 0 or greater than 0. Then the summation of x, or the sum of all probabilities of all ranges of x belong to range of x, would be equal to 1. This is something that we just discussed. So these are two axioms. The value of a PMF cannot be negative and the sum of values would be equal to 1. Now on the other hand, if we are calculating the probability function for a continuous univariate distribution, we have two sort of distribution, univariate and multivariate. This is something that we will discuss later. But univariate is a probability where there is only one factor involved, there is only one probability involved, and in multivariate there are multiple probabilities or multiple events involved. So a probability density function is a function which is referred to the continuous univariate distribution. So probability mass function is for discrete and probability density function is for continuous random variable. Now the other concept, and probably one of the most critical concept, is the cumulative distribution function. So in the cumulative distribution function is the probability distribution that contains the probabilities that a random variable is less than or equal to x. So basically, earlier we talked about the probability of, let's say, going back to the probability. The probability of 1 divided by 6 would be 16.6%. So this is a probability of one function. So if we are calculating probabilities of these, so 1, 2, 3, 4, 5, 6, these are 6 possible outcomes from rolling a dice. The probability mass function would be 16.6%, 16.6%, 16.6%, 16.6%, so on and so forth. So it's equally distributed for all of these probabilities. But for the cumulative distribution function, what we will do is that we will keep adding these values. So the first observation would be 16.6%, but for the second observation we will be accumulating these two observations. So instead of 16.6%, it will become 33.3%. Then for the next value, again we will add 16.6%. So it will be 49.9% and so on and so forth, until and unless for the last observation it will become 100%. So for the cumulative distribution function, we are actually adding these values into each other and then calculating the cumulative probability. So basically we are talking about a particular event. For example, in this particular case, we can say that what would be the probability of x less than or equal to 3. So in this particular case, we will just go here and we will take this probability, that it's basically 49.9%, because in this particular case, we are calculating three probabilities. We are calculating probability of x is equal to 1, probability of x is equal to 2, and probability of x is equal to 3. And we are just adding these probabilities up to calculate the cumulative distribution function or cumulative probability of this event happening. We can express this in terms of Bernoulli random variable, where the CDF would be equal to 0 for all values less than 0. 1 minus p for any range between 0 to 1, and 1 if the x is greater than or equal to 1. Cumulative distribution has a lot of practical significance, and a lot of probabilities are actually built on the basis of CDF. Whenever we are trying to calculate the default rates, we are trying to calculate the probability of default, we are usually using the cumulative distribution function, so as to know that what would be the event of happening this. So if we are interested in here, we would be interested in the earlier events as well, and hence cumulative distribution function or CDF function is considered more critical than the PMF. Now we talk about the CDF for discrete random variable. We can have CDF for continuous variable as well. CDF of a continuous random variable is defined in exactly the same way as the CDF of discrete random variable. So basically the concept would remain the same. In this particular case, for the function, we would be calculating the probability of x less than or equal to b, and we would be multiplying it by fb. Or for the discrete function, we would be representing as a small fx. So a small fx is actually related to discrete, and the capital FB is related to continuous, but both of these are same thing. Now, if we talk about the relationship between CDF and PMF with discrete random variable, the CDF can be represented as a sum of PMF for all values that are less than or equal to x. So basically, we discussed this earlier in the previous example. And then Fx, the summation of CDF would be equal to Fxt, the small individual sum that t belongs to Rx, where Rx is actually the realized value. So these are all possible range of x for which probabilities can be calculated. On the other hand, if we have CDF available, we can calculate PMF using the difference between consecutive value of x. So just to go this particular example, if we had this value available, and if we had to calculate the PMF, we would just subtract, this would remain 16.6 minus 0 because there is no value here. Then it would be 33.3 minus 16.6 and so on and so forth. So if we take a difference of these two observations, we would be coming with the PMF as well. So we can calculate CDF from PMF and we can also calculate PMF from CDF using the differentiation.